Okay, so first of all, for my students, you don't all know Marta Corbin. Marta Corbin is one of our favorite alums, and she got her degree, her bachelor's degree from us years ago, went down to Knoxville to study, and got her master's down there, and came back because her family's all in this area, and was doing some teaching for us. And one summer, Marta and I met, and we just about said the same thing at the same time. I had been to the Ocoee area with my great-nephew, took him on a raft trip, and I was about to say to Marta that we should organize a trip to the Ocoee area. She was at the same time going to say to me, we should organize a trip to the Ocoee, and the rest is history. We've been doing this for about 12 years now. Now you know who Marta is. And at any rate, this is our first stop, and these beds here are different from the beds we've seen at Cagle's Mill. Those of you in my classes, we went to western Indiana and we saw Mississippian and Pennsylvanian rocks. These are older. These are 475 million years old. They're Ordovician rocks. And they're very common in Indiana. They're largely flat-lying here. There's a slight inclination or dip to the west, maybe a few degrees, but we're actually on a very special part of Indiana called the Cincinnati Dome. It's sort of uplifted a little bit, and sort of a structural highland. But these limestones indicate that Indiana was covered by a warm, shallow sea about 475 million years ago, when Indiana was about 20 degrees south of the equator. And these lime-secreting fossils were thriving. There's corals here, and brachiopods and bryozoans. And, some of you found some cephalopods, and Lori, where's Lori? You're right here. Found a cephalopod and some worm burrows, some of the best worm burrows I've ever seen here. You can actually follow the trace of the worms as they made their way through the sediment. Really some good stuff. Thomas found a super snail. I think it's a snail. I don't think it's a cephalopod. Curled. And several years ago, a girl found a magnificent trilobite about this big. We've only found a few fragments. Emily found a trilobite fragment. Where's Emily? Right here. Yeah, Emily found they're right in front of me. I found a trilobite fragment, these little things that look like pill bugs. They're arthropods, but they were very common at this time. So you'll note that these things are in layers. The limestone is kind of blocky, and then there's silt layers in between them. The fossils, the animals, were living when there wasn't a lot of silt. There was pulses of silt coming from farther east during the first mountain building episode of the Appalachians, called the Taconian mountain building episode. And every now and then a pulse of weathering products would be transported down here by rivers and currents, smother the fossils, and then they get reestablished again later. So it was going on for millions of years, actually. And Indiana is has one of the most abundant limey fossil deposits anywhere in the world. These are world-class fossils here, by the way. So, you want to say something, Marta? I'm doing all the talking.
That's all right. I think what I would like to, well, first of all, welcome to all of you. We really enjoy this a lot, which is why we keep doing it. But this is a good opportunity to just kind of to learn how we are able to put the history of the Earth together. And so what you're doing today is you're kind of doing that. Today and tomorrow, you're going to be looking for evidence that, I mean, we tell you that this was a shallow sea. How do we know that? We know that because of all the fossils that we find here, the rock types that we find here, and we can compare those to current ocean environments and say, okay, these guys might be extinct, but they've certainly got relatives that are in the oceans today. So we can make those comparisons, and that's how we're able to determine the history of a particular region. So what we want you to do today while you're here is, first of all, note the variety of different organisms. These are all organisms that had shells. Evidence that there were soft-bodied organisms that all died are those worm burrows. I mean, things that are all soft tissue tends to decay away very easily. But we've got a lot of shelled organisms, so that's what you're looking at here, are all these shelled varieties. And what you're going to also notice is that where we have nice flat-lying rocks here, tomorrow we're not going to see these flat-lying rocks anymore. These are rocks that have all been heavily deformed, and they've been deformed just because of things that have happened to them, mountain building events that have crumpled them, that have caused them to fold. And so the whole suite of rocks, these are all sedimentary rocks. We are not going to be seeing much in the way, we'll see a few sedimentary rocks tomorrow, but by and large we're going to see more metamorphic rocks, and that's about the only ones we'll see. If you go farther east, you would get into some igneous rocks, but we're going to be looking at metamorphic rocks. And those are all rocks that were something else before. Remember, the definition of a metamorphic rock is one that was something else prior, and then it has been changed because of different heat and pressure and hot fluids and things. So we're going to be able to see that transformation. So what is nice about this field trip is we start out with what was basically an ocean environment, very flat-lying rocks, and we're going to go into what is now a mountain building episode and be able to look at all the changes that have taken place. So what we hope you've done here is pick up some of these fossils, which I think all of you have done. Find out what you have. I mean, that's kind of cool, you know? So whoever's van you're in, hopefully there's someone in there that maybe knows the names of these. If not, then ask us tonight or whenever.
Yeah, that reminds me, I do have handouts for everybody in Marta's car, including a handout Marta made of this locality, which identifies all the different fossils for you. So don't go away until I give you those handouts. Okay.
And so anyway, the idea is just, you know, to appreciate what we have here and try to learn as much as you can about, you know, each of our stops along the way. So this is the only geology stop that we're making here today. All the rest of them will be tomorrow morning. So I know we've got some logistical things we need to cover, but anything else you want to say about the race?
Well, yeah, I just want to make sure I say it all here. I want to talk a little bit about the mountain building. So we talk about it again tomorrow, but you'll hear it first today and we can reinforce it tomorrow. As I said, some of the silt in here is being derived from the rising Appalachians to the east, the first pulse called the tectonic orogeny. At the same time, that mountain building was one of the causes of the sea rising and covering over what was then Indiana. And I explained this to my classes. What was going on even farther to the east was convection cells, heat flow in the mantle, speeding up. And that moves the plates around. It also raises the seafloor. And as it raises the seafloor, it raises the water in the sea. And that water rises and flows over the continents. So this Ordovician stuff here was deposited when North America was covered by the most extensive epicontinental sea in all of geologic history. So it's related to plate tectonics, and we'll talk about more of that later. Now, about logistics. You have in those folders I brought for everybody, and I'll give to Marta's vehicle when we get down there. You have the itinerary in a nutshell, and you can study the geology as we drive around Cincinnati, past Lexington, and down to Knoxville. You will see the geology change. As we drive south of Knoxville, You can follow which rocks we are in by that handout called Geology in a Nutshell. There are even pictures of the geology and the maps and so forth. That area that we'll be driving on, that kind of flat platform with ever larger hills, is called the Cumberland Plateau, a highland area that was rammed upwards during one of the latest of the 3 Appalachian mountain building episodes. And as we get down to Knoxville, the rocks are going to become terribly messed up. That's the Cumberland Escarpment, the break between these rising highlands and the Appalachian Ridge and Valley province. These highly folded and contorted and metamorphosed rocks that we will be in tomorrow. My students, I talked about the channeling, river channels that you will see maybe about 80 miles away from Knoxville. You will see them in coal deposits in the rocks as well. There's some pictures in one of your handouts. There are all sorts of handouts to keep you out of mischief as you're driving down the highway. So if you have some time, take a look at those handouts. Now about the logistics, we don't have to all drive in caravan. You can drive at your own rate. Bear in mind that highway going down there south of Cincinnati is a ramp, and the semis are peeling it, and all the cars are as well. I would say that at least 30% of the time